Hello, everybody. Welcome back to Astronomy Videoland. Today, I want to talk about User's Guide to the Sky, Chapter 2, sort of elaborate on the PowerPoint that you've already seen, I hope. And this one, this interesting image right here up in front, shows you Polaris, the North Star, and these are long-term star trails. Takes a few hours to produce something like this. You can see the Polaris is not quite on the North Celestial Pole. I'll tell you what that means in 2 seconds. Okay, constellations, a big deal in this chapter. Turns out that there are indeed 88 official constellations, and the officialness of them is determined by the International Astronomical Union. And they have decided that the entire sky should be covered by constellations. There are no holes. And the idea of what a constellation is sometimes confusing. Everybody knows it involves star groups in the sky. What people sometimes don't realize is that these stars really have nothing to do with each other. They're all at different, they may look in the same direction, but they have different distances. Some are close, some are far away. They have absolutely nothing physically to do with each other. It's a big coincidence, put it that way. We're situated in a portion of the galaxy. When we look out at the 500 billion stars or something, the few that we can see, they happen to line up in certain patterns because where we happen to be, and we, some people thousands of years ago and up to date, even closer to the present, saw things there that they decided to commemorate in terms of constellations. That's really what we're talking about. Now, most of the constellations, by the way, don't look like what they are supposed to be. Here's one that actually does. That's why I have it on the screen. Scorpius is really beautiful. It's a scorpion, and you can see Antares, which is a red supergiant star. Very beautiful, very visible in the sky. This is a star that's going to go supernova someday, that is, blow itself up. Here you can see the 3 pincers, and when we go down the scorpion's body, it ends in a tail, as you would expect. Now, there are asterisms in the sky that are star groupings, but they're not official constellations, or they're just parts of constellations, like the Big Dipper. Everybody probably has almost everybody has seen this one. The stars in that constellation, or that asterism, that unofficial star group, are 75 light years away. That means it takes the light 75 years to get from the stars to us. And but remember, the Dipper is not a constellation; it's simply a group. Star names are important too, just so we can keep track of what we're talking about. A lot of stars that are very bright have proper names, like Antares and Betelgeuse, we'll talk about in 2 seconds, but not all do. And instead of being just referred to as Betelgeuse, we can call it Alpha Orionis, and you see that on star maps like the one you're looking at right now. Alpha is the first letter in the Greek alphabet, which means that Betelgeuse is the brightest star in Orion, at least it was when it was named. The second brightest star would be Beta Orionis. The third would be Gamma. If you're not familiar with the Greek alphabet, you can Google it and then print it out so that you don't feel lost. For example, here in Scorpius, we have Delta Scorpii. That's Alpha, Beta, Gamma, Delta. So that's the 4th brightest star. So anyway, that gives people an idea of how bright these stars are relative to the other ones in the constellation. Now, if you're into constellations, you might get a kick out of this link. You can click on it and find everything you've ever wanted to know and some about constellations. Speaking of constellations, one of the interesting things about constellations is that they vary throughout the year. In other words, there are summer constellations that we see over here during the summer, and there are winter constellations that we see mostly in the winter. This explains this to be strictly due to the Earth's orbit around the sun. Let's take a look at this real fast. Here's the sun. Here's the Earth's orbit. Don't be confused by this oval shaped orbit. Actually, the Earth's orbit is almost circular, but instead of seeing it like this, we're seeing it on an angle, so it appears to be oval. Notice that the Earth goes around the sun. Here we are in December, March, June, September. Here we have several of the constellations that are lined up around are you ready? The ecliptic. That's a good word. The ecliptic is simply the apparent path of the sun in the sky. And these aren't the only constellations in the sky, but they're some of the most famous ones. Let's see if we can see why this works, why the constellations shift with the seasons. Here's June. And if we are on the Earth at June, we're here. If we look in this direction towards the sun, what we see is a very bright sun and a very bright sky. That's called daytime. Which means, by the way, these winter constellations are still in the sky. It's just they're washed out because the sky is so bright. So to see constellations, we have to look away from the sun. That means the nighttime side of the planet. And when we do, we see Scorpius, the one we were just talking about before. Here's Sagittarius, famous because it's the direction to the center of our galaxy. And others, of course, Capricorn, Aquarius, and so forth. Now, what do you do if you want to see winter constellations? You got to wait till winter if you live on the Earth. And so you have to go through 6 months of orbiting, and you wind up over here. Remember, when it was June, all we had to do was look in this direction to see the summer constellations. When we do that from the December point, we're seeing the sun in a very bright sky. That's daytime in December. The nighttime direction in December is to the right, and because the sun is over here, this is night. So we're seeing Cancer, Gemini, Taurus, Orion, and all the other beautiful ones. And that's basically the simple idea behind why constellations shift throughout the year. Now here's the celestial sphere. This basic concept is important, and here you can see the Earth, and here's the celestial sphere around it. It's imaginary, of course. And here's the rotation axis of the Earth, and it goes up. Here's the North Pole. It goes up to and hits the celestial sphere and becomes the North Celestial Pole. Same thing down here with the South Pole. It goes through and hits the celestial sphere and becomes the South Celestial Pole right here. Here's the horizon, depending on where you are on the Earth. And the sun and all the other stars rise in the eastern horizon, go on an arc across the sky, and set over here in the western horizon. And notice that some of these constellations never get below the horizon. That's because of the altitude of the North Star. The higher the North Star gets, the more stars never set. That's the interesting thing. So you can see that in fact, the stars on the edge of this boundary will never actually set. That's true in the southern hemisphere too. These are called circumpolar constellations. So what determines, obviously, if the North Pole or the North Star and the North Celestial Pole get higher in the sky, there are going to be more circumpolar constellations. What determines how high the North Star is in the sky? Very simply, it's the observer's latitude. That's all that does it. And for example, if you have a 30-degree latitude, that means that from the horizon up to the North Star will be roughly 30 degrees. If you're visiting the North Pole by any chance, that has a latitude of 90. That means that the North Star would be right overhead. Okay? So anyway, that's interesting stuff to keep in mind. Now, let's talk about star brightnesses a little bit. The technical term for this is magnitudes. And the magnitude of the star is simply determined by how much energy is hitting per second on each square meter of the surface of the Earth. Just that simple. And that's called a flux. And here we're talking about apparent visual magnitudes. Apparent simply means that's what we're actually seeing in the sky at the moment. Visual means this is the wavelength range that we can actually see. Magnitude relates to brightness. Now that said, the only tricky thing about this is that the bright stars have big negative magnitudes and the dim stars have big positive magnitudes. So big magnitudes means dim objects. Small magnitudes and big negative magnitudes mean bright objects. Let's take a look at this in detail. The naked eye limit is 6 plus 6. That means anything dimmer than 6, that means bigger than 6, will be your eyes will be unable to see it without binoculars and telescopes. The North Star, look at this, is about plus 3. That's kind of a moderate star at best. Sirius is the brightest star in the sky. And it is about, you can see, roughly -1. By the way, don't be confused. This is a common misconception too. Magnitude 0 does not mean that the star has no brightness. See, this can be a little confusing. Magnitude 0 is a pretty bright star. That would be a star just a little dimmer than Sirius. Now, Venus is a bright planet. You've all seen it either in the west or in the east near the horizon. Notice it's -4. Very negative and very bright. Full moon's even brighter, that's -12, and the sun wins the brightness sweepstakes at -26. Notice way over here on the right where we have very large positive magnitudes that mean very dim objects. That's where the Hubble Space Telescope observes. Now, just for fun, I'm going to mention a couple of misconceptions that Seeds likes to talk about in the book. And I think these are interesting because the problem with them is that people that, for whatever reason, believe in them, and I have friends who believe in these common misconceptions, by the way, sometimes miss out on what really is going on. So let me give you an example of this. Some people assume that stars are not, N-O-T, in the sky during the day. After all, we can't see them during the day. And of course, as we saw earlier, stars are always there. It's just that the daytime sky is too bright for us to actually pick them up with the naked eye. Now, this was one I had never heard myself. The second one, others think that the North Star, which is Polaris, is the brightest star in the sky. Now, why would anybody think that? I think it has to do with the fact that it's so important. In other words, the North Star is the North Star. The entire sky appears to turn around it. Now, actually, it's only the 51st brightest star in the sky, and you saw that on the magnitude diagram before. It's not one of the brighter ones. The brightest star, of course, is Sirius, which is not far from the well-known constellation Orion, which is cut off by my little box that I'm trapped in here. Anyway, so that's it for Chapter 2, and next week we'll go a little further with the next chapter. See you then.